Hi, I'm Dr. David Targan, and welcome to BioDigest. Plastic, from soda bottles to keyboards to the inside of your car, plastic is everywhere. It's a strong and durable substance that lasts virtually forever. But that's part of the problem. Billions and billions of pounds of plastics are produced and discarded each year, and all this waste is piling up.
The amount of plastics produced annually throughout the world is close to £500 billion per year. You know, society has become extremely dependent on plastics for everyday living. I mean, most of us don't notice them, but they're basically everywhere.
Approximately 10% of the petroleum used in the world today goes into the production of plastics. Your toothbrush and your razor handle in the morning, the things you see around your office, such as pens, copy machines, your cell phone case. How do you carry your lunch home from the convenience store? You would see that's a plastic bag.
Currently, those plastics are made entirely from petroleum, natural gas, and oil. However, those resources are being depleted.
Metabolics, a Massachusetts-based biotech company, is reinventing how plastic is made.
So this is where all the action takes place. This is where the path-breaking technology for Marel, Metabolics' biodegradable plastic, works. What you're looking at here is the actual broth producing these microbes that are producing polymer.
This new family of plastics capitalizes on the natural plastic-producing abilities of microorganisms.
In nature, microorganisms for millennia have been producing these natural plastics inside their cells, essentially as a storage material, much like we store fat or you store starch inside a corn kernel. The difference being that chemically, these plastics are polyesters. And polyester, as we all know, essentially is a plastic material. To make the Marel bioplastic production technology, what we did is we took those pieces of genetic code, DNA, we took them from a range of different organisms and we repackaged them, essentially like taking different pieces of software and building a new platform inside a living organism so that they can then produce Marel bioplastics.
That's right, organisms making plastic.
So it starts with our feedstock. Corn is our feedstock. From the corn, we pull corn sugar, or glucose. This glucose is used to feed these engineered microbes to produce this polymer. We harvest that polymer from the microbes, turn it into pellets. The same types of pellets that are used to develop plastic all over the world, we turn those into various consumer applications, from injection molding to sheet to blown film. Now, at the end of their natural, useful life, rather than being persistent waste in the environment, they can harmlessly biodegrade back into water, CO2, and biomass.
The plastic that a consumer will see, based on Marel, will be virtually indistinguishable from the plastic you're currently using.
Plastic has been made a certain way for decades. Marel is beginning to change the way people think about plastic.
The chief obstacle is really convincing folks you can actually do this, that you can actually make a bio-based plastic that's as useful and as durable in all of the uses that the folks use the existing plastics for today. And the beauty of what we've been able to do in terms of those plastic pellets is to formulate them so that those pellets will run in the existing plastics processing equipment required to make things like films for bags, molded goods like, toothbrushes, that type of thing. We're going to sell these little plastic resin pellets, but they're going to be converted into things that we see in everyday use. Just one example here. This is a gift card, which is actually, I believe, was in the stores this year. And so, to the normal person in the street, this just looks like an everyday, ordinary gift card, same as you would get with any other material. The difference being it's made from a completely bio-based bioplastic.
Metabolics isn't stopping with Marel bioplastic. They are already researching and developing more efficient techniques for producing natural plastics.
The lowest cost form of sugar available today in large scale is basically corn sugar. However, we also engineered into these organisms the ability to use sucrose from cane sugar, or ultimately to use cellulosic hydrolysate sugars as those technologies become available.
Cellulosic hydrolysate sugar comes from the non-edible parts of plants, like the stalk, trunk, or stem.
Interestingly enough, the next phase of that is to have the plant crops produce the Marel bioplastic directly inside the green tissue of the plants.
This is switchgrass. otherwise known as prairie grass, that covered the plains of North America from Mexico up to Canada. This switchgrass here is actually producing plastic in the leaves and stems. We'll harvest this plastic, turn it into everyday pellets to produce all types of products, from compostable bags to packaging to consumer products, business products, that at the end of its useful life will harmlessly biodegrade back to nature again.
Metabolics is one of the many biotechnology companies discovering better, more sustainable ways to create products like plastic that are such a part of our modern lives. For BioDigest, I'm Dr. David Targan.